Let's look at this example. We have this company, Iron Goods, deliver goods to 8 towns. And the location and the demands are shown in the next slide. And he wants to find the location for a logistics center so that can minimize the average delivery time to this town. So where should he locate his logistics center? So here is the 8 towns that he has delivered the product to. The blue number is the demand. For example, in the town CP, the demand is 25. And the distance, the green color is the distance from one town to another town. For example, 22 is the distance between the town AL to CP. And 15 is the distance between the town AL to BE. Okay. So from AL to BE, okay, AL to BE, we can see the shortest way is 15, right? So the distance between AL to BE is 15. How about from AL? Let me change another color. AL to EN. So we have several ways to go from AL to EN, right? So we can see we can go from AL to BE, then BE to BI, then from BI to EM. It's follow the red way, the red line. So we have the distance is 15 plus 9 plus 7. So we have, if we follow the red way, we will have the distance is 31. We also can have another way to go to EM from AL, like AL from BE, then from BE go to CP, CP go to FR, then FR go to EM. Follow the green line. So the distance, if we go this way, is 15 plus 8 plus 6 plus 6. So the total is 35. We also can go another way, that is the yellow way, from AL to CP, CP to FR, then FR to EN. And the total distance to go from AL to EN, follow the yellow line, is 22 plus 6 and plus 6. So we have 34. So on and so forth, we will find all the ways that we can go from AL to EN. And we compare, then we can see if we go follow the red way, the distance is the smallest, so 31. So we don't care about other distance, other value, we just care about the smallest value. So we assume that the distance from AL to EN is 31. So the same, you can find the distance from AL to FR or AL to BI or BE to GO, for example. So we will have the distance matrix with this. So here we can see from AL to AL is always to be 0, right? Then AL to BE is 15, the distance, the smallest distance. AL to CP is 22, AL to BI is 24. This one is the distance matrix. So if you want to check if it's correct or not, you can check this one, the first slide. So if it's a distance matrix is correct when this one has to be 0, this line, or 0. And the column B is the weight or the load of that town, like how many sheep, how many trip, or how many products how many units they have to deliver the products to AL. Is 10. Okay, then the next step, after we know the distance and the weight is the input, and the distance is you have to find by yourself the smallest distance. So we can calculate the weight distance value. So for AL, we will have 0 times 10 plus 15 times 15, then 22 times 25, BI 24 times 20, so on and so forth, until HT 36 times 15. Then you take the sum of all the weight distance, so you can calculate the value of the weight distance of a center at AL. Then you can see here is the weight distance of a center at AL. Here is the total weight distance of a center at DE. So we compare those numbers, and you can see that if we locate the facility, the logistics center in EN, it will occur the smallest value of the weight distance. So we choose EN to be the single median.